optimize the that is inhaler mouthpiece design. Only the 22 that is percent of asthma medications are delivered to the lung because of the barrier nature of the respiratory tract and medication loss in the inhaler during the inhalation process. The medication loss is a most critical and not at all acceptable. It means if you don't get the proper dose, that is you will not get cure. That is though our that is using the mouthpiece for an example, that is developed a methodology that allows inhaler design to be optimized. So number one, then normally that this has been observed, there's computational and experimental approach to design and optimize mouthpiece for a new prototype inhaler that that is minimizes the amount of medication lost on the mouthpiece. The analysis processes uses in vitro experimental studies of aerosol performance is an initial prototype mouthpiece to validate, develop computational fluid dynamic method for the aerosol inhaler. So then CFD model to that is quantify analysis, that is for relationship between mouthpiece drug that decomposition with resulting aerosol transport condition to identify critical design attributes. This is the most critical. During the design phase, these relationships are used to modify in the design of the device, the mouthpiece designed to target the desired critical design attributes. So those who will design, you can design this mouthpiece, you can take the help of artificial intelligence, you will get perfectly so perfect design. The modified design is tested experimentally to verify that is agreement with the CFD model prediction deposition and the CFD and is vitro guided design process repeats as needed to achieve the required mouthpiece performance criteria. Performance of the final optimized mouthpiece design should then be verified using vitro experiments. So you have to make the design, you have to take the trial, design validation is required. By minimizing the drug deposition, the most important factor, critical challenges, deposition with the mouthpiece, we can increase the amount of drug available to the patient for inhalation and increase deposition within the airways. With our research, that is, we were not looking to develop a generic mouthpiece design. Rather, we want to illustrate a rational design methodology that would be beneficial during any inhaler design process using this combined computation and experimental analysis and design approach. So the most important thing we observe, that is after inhalation, so few that is drugs are accumulate in the mouthpiece, also that is in the lung itself deposition. An optimized inhaler design could reduce the velocity at which the spray is delivered from the inhaler, so reducing that is impaction deposition of the mouthpiece and patient throat. These will improve both drug delivery efficiency and reproducibility. So what are the next generation design? The next generation pharmaceuticals to be delivered to and via the respiratory tract may not have the large therapeutic window that is generally seen with today's inhaled drugs. next generation inhaler design that improved drug deposition efficiency and reproducibility. Therefore, we required for next generation systematic drugs delivery. Thank you very much. Like and subscribe.